If you are pasting your company's financial data into ChatGPT and asking for a forecast, you are playing Russian roulette with your career. We love large language models.
Look, it's finally working. I optimized the sequence.
They are amazing at writing emails, coding, but structurally, they are terrible at tabular data. I'm going to show you why they fail. It's not a bug, it's their architecture.
The integrity of this neural network relies entirely on the parameters we establish here in the core. Data flow must remain uninterrupted for the simulation to hold.
And then I'm going to show you the new architecture that is replacing them for structured data. Large tabular models, LTMs. Here is the fundamental problem. Large language models don't see numbers. They see tokens. When you type 1000, ChatGPT doesn't see the value 1000. Depending on the tokenizer, it might see 10 and 0, 0. It predicts the next word based on probability, not calculation. This means LLMs bias towards the average. They try to write the most likely text. But in data science, we don't want the likely answer. We want the outlier. We want to find the fraud, the anomaly, the market crash. Large language models smooth those out. Tabular models hunt them down. This is where large tabular models, or LTMs, change the game. Unlike an LLM, which is trained on text, an LTM like TabPFN is trained on math. It hasn't just read the internet. It has been trained on millions of synthetic datasets. It knows what a linear relationship looks like. It doesn't guess the next number based on grammar. Calculates the probability based on the actual data structure.
Look, it's finally working. I optimized
The magic is something called in-context learning. With XGBoost, you have to train and tune. With TabPFN, the model is already trained. You just feed it your spreadsheet, and it understands the pattern instantly, in a single forward pass. So stop forcing ChatGPT to do math. Use the LLM to write the code. But use the LTM to run the numbers. I've dropped the Google Colab notebook in the description below so you can try it yourself.
Please note before start, create a Hugging Face login and create a token. Also agree for the terms and conditions for the TabPFN_2_5 model. In the video description, I am giving you the two codes, separately one with CPU and other with GPU. Okay, look at the result. We just fed it raw medical data, 30 different measurements of cell nuclei. Usually, I'd have to spend an hour tuning an XGBoost model to get this right. TabPFN just looked. Okay, I'm running this on a standard CPU, so it takes about 90 seconds to process. And we're done. 97.3% accuracy. Now, you might say, 99 seconds? That's slow. It may drop to around 50 seconds even with CPU. But think about the alternative. To get 97% accuracy with a normal model, I would have to spend hours cleaning data, tuning hyperparameters, and retraining. Here, I waited 90 seconds, drank some coffee, and the AI did all the work for me. That is the trade-off of large tabular models. You trade raw compute time for human time. Okay, now let's enable GPU in Colab free tier, and results in 5 seconds, a huge improvement over previous 90 seconds with CPU. It gave us 97.34% accuracy. It figured out the difference between a safe tumor and a cancerous one without me writing a single line of training logic. That is the power of a large tabular model.
This is IT Trends X. I'll see you in the next one.